The equation in example 3D is log base 5 of 3x plus 2 plus log base 5 of x minus 1 is equal to 1. This logarithmic equation is different than the ones we've previously seen because there's more than one logarithm present. On the left side, we have two base 5 logarithms, okay? What we've had so far, okay, is just each equation had a single logarithm, and we know the protocol for solving a logarithmic equation that can be written as one single logarithm is equal to a number, okay? So that's not what we have here. The good news about this equation is that the right side is what we want. The right side is just a number, but the left side is not a single logarithm. Okay, the good news is that since they have the same base and we're adding them together, we can condense them into one base 5 logarithm according to the three major properties of logarithms. So if we go back to the bottom of page 3, okay, what we have in our situation is we're adding two logarithms and we want to convert them into one logarithm. So we're going to use this first property here where we're adding two logarithms, and we're going to apply this property in this direction. Addition will turn into multiplication. Okay, so we'll be able to condense them into one logarithm of the same base. Okay, all we have to do is take the quantities that we're taking the logs of and multiply those guys together. So let's do that here. All right, so the left side is going to become log base 5 of, okay, addition will turn into multiplication. So I need to take this quantity, okay, I'm going to keep it in parentheses. So 3x plus 2, and I'm going to have to multiply it by this quantity. Okay, so times x minus 1, keep it in parentheses. Okay, so that's how these two logarithms combine into one. You absolutely have to keep the base of 5 on there. Okay, that's very important. Okay, so that's great. The left side of the equation is now a single logarithm. The right side is just a number. So we've got a logarithmic equation that fits the bill. We've got one logarithm equal to a number. Okay, so at this point, since we have what we need, we can go ahead and apply the arrow definition of a logarithm to get rid of the logarithm. So if we take the base 5 and raise it to this power, we're going to get this quantity. Okay, so if we do that, that's going to tell us that 5 to the first power is equal to the quantity that we're taking the logarithm of, which is 3x plus 2 times x minus 1, and yay, the logarithm is gone. Okay, so this should be an equation we know how to handle. Okay, 5 to the first power is 5. I'm going to go ahead and multiply out the right side, so FOIL it. So 3x times x is going to give me 3x squared. And then if I multiply the outer terms, 3x times negative 1 is negative 3x. Multiply the inner terms, so that's going to be 2x. So plus 2x. And then multiply the outer terms, 2 times negative 1 is going to give me negative 2. Quick scan here, you can see this is a quadratic equation. Okay, so we need to combine like terms and we need to make one side 0. Okay, I can combine these x terms here. So I'm going to get, let's see, I'm going to get 5 is equal to 3x squared minus x minus 2. And to get one side equal to 0, I'm going to subtract the 5 from both sides. Okay, so that will bring me to right here. 0 is equal to 3x squared minus x minus 7. Okay, so to get our potential solutions for this logarithmic equation, I need to solve this quadratic equation. Okay, one side is already 0, so either factor the non-zero side or apply the quadratic formula. Okay, this might take me a couple of minutes to factor. I'm going to go ahead and just go straight to the quadratic formula. Okay, so here a is the number in front of x squared, that's 3. B is the number in front of x, that's negative 1. C is the constant, -7. Plug all of this information into the quadratic formula. So x is going to be negative b. Be careful here because b is already negative. So you've got negative b. That's going to give you the negative of -1. Plus or minus the square root of b squared, so -1 squared, minus 4 times a times c, all over 2 times a. Okay, so this is how you plug everything into the quadratic formula. Now we need to simplify. Okay, so we're going to get x is the negative of -1 is +1. Underneath the square root, we've got -1 squared, that's +1. Negative times negative is positive. 4 times 3 is 12. Times 7 is 84. And the denominator is 6. So if we simplify here what's under the square root, we're going to get that our potential solutions here in exact form are x equals 1 plus or minus the square root of 85 divided by 6. Okay, and we can't simplify this any further. Okay, now although this is a pretty complicated looking answer, okay, you do have to check your solutions in the original equation. Okay, so let's do that. All right, notice the quadratic formula is going to give us two potential solutions. One by picking the plus in the middle, one by picking the minus in the middle. Okay, so I'm going to write this out here. Okay, so the first potential solution is you get that by picking the plus in the middle. So 1 plus the square root of 85 over 6. Okay, I have to check that in the original equation. Okay, just to make sure that if that's my x value, I don't end up taking the logarithm of a negative number or of 0. Okay, this is how I'm going to do it because this is complicated. I'm going to get a decimal approximation. I'm going to use the calculator to help me check this. So I'm going to do 1 plus the square root of 85. This is the numerator. I'm going to divide by 6. Okay, so here is the potential solution. Okay, so it's approximately 1.703. So I'm going to jot that down. 1.703. Okay, and I need to see if this is my x value. Okay, does it work in the original equation? Okay, so you have two base 5 logarithms on the left side. Okay, it's okay, it doesn't matter when you're checking that the base is 5. Okay, we just need to make sure that if we pop this in as the x value, the quantity that we're taking the logarithm of is not negative or 0. Okay, you have to check both logarithms. So I'm going to focus on the first logarithm. I'm taking the logarithm of 3x plus 2. Okay, that needs to be a positive number to take the logarithm of it. Okay, so here's what I'm going to do. Okay, this is my decimal approximation. I'm going to store it in my calculator. So see where my arrow is? I have this store button. I'm going to store it in the letter A. So I'm going to hit alpha A. And now every time I call up A, that's going to be my x value. Okay, so if I do 3a plus 2, that's the first quantity that I'm taking the logarithm of. That's a positive number. So it's gonna work out. Okay, now just because the solution is good for the first logarithm, you still have to check the second logarithm. Maybe it works for the first logarithm, but not the second logarithm. So in the second logarithm, the quantity that we're taking the logarithm of is x minus 1. So we need to take our solution, which is a, subtract 1, okay, and when we do that, we're going to be taking the logarithm of 0.703, blah, blah, blah. So we're good there because, again, we'd be taking the logarithm of a positive number, and that's okay. Okay, so that tells us that this first potential solution is viable. Okay, so this is a solution to the original equation. Okay, now let's check the other potential solution. Okay, so the second potential solution we get by picking the minus sign in the middle. Okay, we're going to do the same thing. Okay, let's look at the decimal approximation. Okay, so I'm going to do, let's see here, 1 minus the square root of 85 to get the numerator. Divide this by 6. So the potential solution here is negative 1.370. Okay, so negative 1.370. Okay, I need to see if this works in the logarithms in the original equation. Okay, I'm going to do the same thing. I'm going to store this in A. Okay, now I'm going to plug this in to both logarithms. The first logarithm, the quantity that we're taking the logarithm of, is 3x plus 2. So let's see what happens. If we do 3a plus 2, we'd be taking the logarithm of a negative quantity. That's bad, bad, bad. Okay, so it doesn't work. Since it fails in the first logarithm, you don't even have to check the second logarithm. Okay, if this answer did work in the first logarithm, you still would have to check the second logarithm. Okay, so it has, if you have a potential solution for it to ultimately be a solution, it has to work in both logarithms, all the logarithms in the original equation. Okay, so the second potential solution does not work. I'm going to scratch it out. Okay, and this is the only solution to the original equation. 1 plus the square root of 85 all over 6, which is approximately 1.703.